to bring water and food where there is only parched earth, and people where there is desolation. To bring freedom of movement where there are imposing barriers, and commerce where nature has decreed there will be isolation. To bring forth a wealth of materials where there are vast untapped resources, and a wealth of knowledge where there is uncertainty. To perform a multitude of peaceful tasks for the betterment of mankind, man is exploring a source of enormous, potentially useful energy, the nuclear explosion. He sees the potentials and he sees the problems. To investigate both and to develop the technology that will turn potentials into realities, the United States is conducting, for the benefit of all nations, a program it calls PLOWSHARE. Today, this scene of preparation for a peaceful nuclear explosion is at an experimental site. Tomorrow, when the potential of nuclear explosives is fulfilled, this scene will move to the site for a new harbor, canal, or mountain pass, a mine, oil field, gas reservoir, or water storage basin, or perhaps a new underground laboratory. Whatever the site, and wherever in the world it might be, the experts participating in the event will be the same as they are here: engineers, scientists, public health authorities. But eventually, the badges of national government will give way, except for control of the explosive, to the hard hats of industry and public works personnel, using this new power tool for their own applications under established safety regulations. This is the day of reality that PLOWSHARE is working to fulfill, when it can deliver to mankind a proven tool and a proven technology. Mankind wears many faces, lined with suffering from many different hardships. But there is a basic, frustrating problem common to all. Many of mankind's pressing needs can be accomplished only by undertaking earth-breaking and earth-moving projects that are too large or too costly with today's energy systems. Man has performed useful tasks with conventional explosives for centuries, but he has recognized and lived with their limitations. He knows that a conventional chemical explosion releases the energy that bonds atoms into molecules. But he also knows now that there is a far greater source of energy within the atom itself, the energy that holds together the heart of the atom, its nucleus. This is the energy released in a nuclear explosion. Energy so enormous that man must express the yield or energy release of nuclear explosives in terms of the tons, thousands of tons, or millions of tons of TNT required to produce an equal amount of explosive energy. But in grasping the full potential of peaceful nuclear explosives, man looks not only to their great energy, but also to their relative size and cost. He sees that a 10-kiloton nuclear explosive, for example, could be as small as 15 inches in diameter and 3 feet long. The price would be about $350,000. The equivalent 10,000 tons of TNT would fill a sphere about 73 feet in diameter with a price tag of about $5 million. Furthermore, if he increases the nuclear yield 200 times, up to 2 megatons, the package is only about 2 feet greater in diameter and 7 feet longer, and the price barely doubles. To increase the yield of the TNT 200 times, he would have to increase the size of the explosive 200 times, ending up with a pile of TNT weighing 2 million tons, which would fill a coliseum twice. And at the same time, the price of the TNT would increase 200 times, up to more than $1 billion. Enormous energy, relatively inexpensive, compact and easily transportable. This is the new power tool that PLOWSHARE would add to man's resources of useful energy, to do jobs never before practical or even possible. Man had speculated on the peaceful potentials of nuclear explosives even before using them in time of war. It wasn't until the mid-1950s, however, that definite plans began to take shape. The United States Atomic Energy Commission was already conducting the Atoms for Peace program to benefit the health and welfare of men everywhere, developing, encouraging, and supervising the peaceful uses of nuclear radiation in science, medicine, industry, and agriculture, and of nuclear power for generating electricity. In 1957, the Commission expanded Atoms for Peace with a new program, Peaceful Nuclear Explosives. The program borrowed its name from words of the prophet Isaiah, in keeping with its goal to beat the destructive blade of the nuclear sword into a plowshare that would cut deep into the earth for the betterment of all mankind. Overall technical responsibility for PLOWSHARE is assigned to the Atomic Energy Commission's Lawrence Radiation Laboratory at Livermore, operated by the University of California. The specialized resources of other Commission laboratories are also brought into the PLOWSHARE effort for major research and development work, plus the special capabilities of various government agencies, private industries, and educational institutions. The task that faces the PLOWSHARE team is to explore and develop safe, efficient nuclear explosives and a practical, effective way to use them. Safety and technology, the two inseparable parts of the PLOWSHARE program. To accomplish this imposing task involves more than conducting new field experiments. It involves delving deep into the storehouse of knowledge man has collected on explosive technology and safety. Centuries of mankind's experience with chemical explosions, and more than 20 years of experience with nuclear explosions. Hundreds of nuclear explosions set off in the atmosphere, in space, underwater, and underground, in a variety of climatic conditions. All of this explosive experience combines to give PLOWSHARE the foundation for building its own specialized technology. And it provides the basis for safety standards that govern all of PLOWSHARE's field experimentation. Before each experiment, experts in geology, seismology, hydrology, meteorology, radiobiology, and many other fields bring their specialized knowledge and equipment into the field. Working with public health authorities, they assure that the specific experiment is being conducted within accepted safety standards. This same thorough investigation will precede the actual applications of nuclear explosions wherever and whenever they may be. What are these actual applications? Some will be dramatic in their effect, as nuclear explosions move huge masses of earth in excavation jobs, reshaping the geography of the land in dimensions never before possible to meet the needs of man. Needs he can see as he struggles against the geography nature has pitted against him. The physical effects of other nuclear explosions may never be seen by the people they serve, as the explosions are set off deep underground to shatter large masses of rock in underground engineering jobs. Other nuclear explosions will be set off to harness the instantaneous release of neutrons, extreme temperatures, and enormous pressures for scientific purposes. These will influence man more indirectly. He may never realize that his daily life has been bettered by the unique research investigations made possible with nuclear explosions. These are the types of applications that PLOWSHARE is working to make possible through research and experimentation, in the laboratory and in the field. The prelude to the full scientific exploitation of nuclear explosions took place before the eyes of observers from nations all over the world. It was the first field experiment of the PLOWSHARE program, Project Gnome. December 1961, 25 miles southeast of Carlsbad, New Mexico. A 3-kiloton nuclear explosive was detonated in a salt bed deep under the Earth's surface at the end of this 1,000-foot-long access tunnel. Several months after the Nome event, reporters and photographers gave the world its first look at a nuclear blasted laboratory. And PLOWSHARE experts weathered the 140-degree heat to gather first-hand information of scientific significance. But even before this actual entrance into the cavity, instruments and Earth samples had provided valuable scientific data. Earth motion studies made during the Nome explosion added to scientists' understanding of the Earth's structure throughout a large part of the United States. In a neutron physics experiment, scientists were able to capture, analyze, and measure some of the enormous quantity of neutrons released in the explosion, an important step in expanding man's fundamental knowledge of the structure of matter. Laboratory analysis of samples taken for isotope studies showed that nuclear explosions are a new potential means of mass-producing radioactive isotopes to meet the expanding needs of science, medicine, industry, and agriculture. But this was only the beginning of what promises to be one of the most significant scientific contributions of nuclear explosions. For it appears that man may now have within his reach a key to understanding many basic processes of nature. This key may be forged by a nuclear explosion. In 1964, important steps in this direction were taken in experiments with nuclear explosives specially designed to produce high-intensity neutron radiation, the specific characteristic that promotes isotope formation. In 100 millionth of a second, more neutrons were released by each explosion than could be released over decades in the most efficient nuclear reactor. The blast pumped these neutrons into targets of uranium, producing isotopes of very heavy elements beyond uranium. Eventually, PLOWSHARE scientists hope to use these heavier elements as targets in nuclear explosions. The result could be the production of new elements never before created by man. This may be the key to answering basic questions about nature man has asked since the beginning of time. There is another question man seeks to answer, a question that raises an even more pressing problem. How can the recovery of natural resources be increased to meet man's ever-growing needs? PLOWSHARE underground engineering may be one of the answers. Nuclear explosions deep underground break and splinter huge areas of rock. These massive effects may permit highly promising recovery of resources that have been impossible or economically impractical to extract from the Earth. By digging tunnels deep into the explosive region, PLOWSHARE teams have been able to examine and evaluate the effects of underground engineering with nuclear explosives. Effects achieved with various explosive yields in various types of rock. Industries and research institutes in the United States and in various parts of the world have recognized many potential uses for PLOWSHARE underground engineering. They can see how nuclear explosions could increase both the total recovery and the rate of recovery of vast natural gas and oil reserves by effectively breaking the rock so that these valuable resources can flow through. They can see how copper could be extracted from the ground more efficiently as nuclear explosions shatter the surrounding rock, letting through the solutions that dissolve the copper and carry it to the surface. They can see how the huge area of broken and fractured rock could be used for receiving as well as releasing materials, for storing natural gas near its market area, for storing rainwater that could seep down underground where it wouldn't evaporate, or even for disposing of chemical waste materials to underground formations. The mining industry has seen another significant potential for underground nuclear engineering. This potential was actually demonstrated in simulated mining operations following underground nuclear explosions. Nuclear explosions would break and crush mineral deposits, perhaps more efficiently than ever before, prior to extracting the ore by conventional underground mining techniques. Minerals, natural gas, oil, water. Investigation and development continue with government and industry working hand in hand to see exactly what role PLOWSHARE underground engineering can play in developing these valuable natural resources.